Hello friends, welcome to Civil Engineering exam. Today we are going to see the problem related with water supply engineering in the topic of sedimentation tank. So the problem is 2 million liters of water per day is passing through a sedimentation tank which is 6 meter wide, then 15 meter long and having the water depth of 3 meter. Okay, so first thing is we have to find out the detention time for the tank. So second question, what is the average flow velocity through the tank? Then third question, if 60 ppm is the concentration of suspended solid present in the turbid raw water, then how much dry solids will be deposited per day in the tank, assuming 70% removal takes place in the basin and the average specific gravity is of the deposit is 2. So the next question, compute the overflow rate. Okay, so the 4 questions are there asking. So first thing we have to find out the detention time. So the detention time is how much time required to treat the water. So that is the water stored in the sedimentation tank. So that is capacity of tank divided by discharge. Okay, so the how much time required. Okay, so that's why we putting capacity of the tank divided by discharge, the capacity in meter cube and discharge in meter cube per hour. Okay, so the meter cube will be cancelled, the hour is the only time unit. Okay, so now we can find out the capacity of tank. Capacity volume equal to L into B into D. Okay, so now this given, that is length is 15 meter long into width is 6 meter into water depth is 3 meter. So solving this we got the value of 270 meter cube. Okay, discharge also given, that is 2 million liters. So the Q equal to 2 million liters. Okay, so now we can find out liters per day. We can convert into meter cube per hour. So 2 into million liters, we can put 10 power 6 divided by, so now we can convert into meter cube, so that is 10 power 3 into 24. Okay, so this is in day, we can convert into hour. So now we got the value of 83.33 meter cube per hour. Okay, so now we can substitute all the values over here. So now the capacity of tank is 270 divided by 83.33. Okay, so now the detention time will be 3.24 hours. Okay, so this is the first question answer. So second question is average velocity through the tank. So velocity, so now we know the formula, discharge divided by cross sectional area. Okay, so discharge in meter cube and area in meter square. So now we got the value of meter per second. Okay, so now the velocity in the unit is meter per second. So discharge is 83.33 meter cube per hour divided by the cross sectional area. So the cross sectional area is B into H, that is 6 into 3. Okay, so now we got the value of 4.629 meter per hour. Okay, so now we can convert into centimeter per minute. So now for centimeter we can multiply it by 100 divided by for hour we can minute we can divide it by 60, that is equal to 7.72 centimeter per minute. Okay, so now we can convert into mm per second also. Okay, so next thing is third thing. So third question, the mass of suspended solids. So first thing is we have to find out the quantity of suspended solids. So now the total quantity of water intake is 2 into 10 power 6 million liters. So the concentration of suspended solids is given, that is 60 ppm, so parts per million. So now 60 divided by 10 power 6. Okay, so solving this we got the value of 120 liters. Okay, so now we can convert into meter cube, so that is 0.12 meter cube. Okay, so next thing is the specific gravity is given, so deposited material is 2. So now we have the density, so density equal to 2000 kg per meter cube. Okay, so now the mass of suspended solids is 70% removal. So now the 70% removal is given, that is equal to, so now the quantity of suspended solid is 0.12 into 0.7, that is 70% of removal, into the specific gravity is 2000. Okay, so 2000 kg, so that is equal to 168 kg is the answer. Okay, so the quantity of suspended solids is 168 kg. Okay, so next thing is fourth thing, the overflow rate. So the overflow rate is discharge per plant area, so that is Q divided by B into L. Okay, so the velocity is we can find out discharge by cross sectional area, but overflow rate we can find out from the B into L. Okay, so now we can take, this is the tank, so this is the width, this is length, and this is depth. Okay, so now the velocity is the water inlet is here, the water outlet is here, so the velocity is based on the discharge by this cross sectional area. Okay, so this cross sectional area, but the surface overflow rate, so overflow rate is mainly based on the this area. Okay, so now the surface area is for responsible for overflow rate, and velocity the cross sectional area is responsible. So now we can take Q into B into L. So now the Q is 83.33 divided by B into L. So B is 6 into 15, L is 15. So now we got the value of 926 into 10 power 3 liter per hour per meter square. Okay, so this is the final answer. Okay, so this is a method we can solve the problem. Again, we will see next video. Thank you.